In this video, we're going to continue our discussion with estimating a population proportion. So, obtaining a confidence interval for a population proportion. Remember, in general, for a confidence interval, it's the point estimate plus or minus the margin of error. Well, we know the standard deviation of the distribution of the sample proportion is given. So now we can write the lower and upper bounds for this. I will write those out now. Okay. So the lower bound, p hat, that's the point estimate, minus z sub alpha over 2 times the standard deviation. And the upper bound is exactly the same as the lower bound, except instead of it being a minus, it's a plus in between. All right. Suppose that a simple random sample of size n is taken from a population, or the data is a result of a randomized experiment. A 1 minus alpha times 100% confidence interval for p is given by the following quantities. So I'm going to rewrite the lower bound and the upper bound now. So p hat plus or minus z sub alpha over 2 times the standard deviation, where n times p hat times 1 minus p hat is greater than or equal to 10. This will prove that the sampling distribution of the sample proportion, or p hat, is approximately normal, and n is less than or equal to 0.05 n. The sample is less than or equal to 5% of the population. Okay? So again, confidence interval, point estimate plus or minus the margin of error. So the margin of error in this particular case, I'll call it capital E, is equal to c sub alpha over 2 times the standard deviation. Remember, the margin of error determines the width of the confidence interval. Okay, let's take a look at an example. In a survey of 517 music teachers, 403 said that the video games Guitar Hero and Rock Band have a positive influence on music education. We want to construct a 95% confidence interval for the proportion of music teachers who believe that these video games have a positive influence. Make sure to interpret, and don't forget to verify that the requirements have been met before creating this. Okay, first thing, we'll write out the first two conditions now. Okay, this is a simple random sample, and 517 is less than or equal to 5% of the population of music teachers. Okay, third we need to check is what? That n times p hat times 1 minus p hat is greater than or equal to 10. Well, first off, before anything else, we need to be able to figure out what p hat is. So we can put p hat here. That is going to be what? 403 divided by 517 to 4 decimal places. That gives me this. Right? So for us, n is 517, p hat, 1 minus p hat. Multiply these together and we get this, which is certainly greater than or equal to 10. You could even round to the nearest integer, which would be 89. 89 is greater than or equal to 10. Okay, so what does this mean then? The shape of the sampling distribution of the sample proportion, p hat, is approximately normal. Okay, I will show how to do this using the formula one time. But no, I will not ask you to do this on a test. I'll expect you to be able to do this into the calculator. Okay, so let me set up the lower bound and upper bound formulas now. Okay, so let's start with the lower bound. So we know p hat is approximately this. Now, for z sub alpha over 2, I'm going to draw something up above here. All right, so I draw the 95% confidence here. Now, remember what we're doing. It's at the very end, and we're going to the left. This is inverse norm into the calculator, which is going to be what? 97.5% as a decimal, that's 0.975, comma the mean, 0, comma 1, when we do these inverse norms. And rounding that to 2 decimal places, that's going to be 1.96. So again, that's going to be my z sub alpha over 2. And plug in for the standard deviation. So when we do all of the arithmetic for this, I get this. Now, the upper bound is exactly the same, except it's going to be a plus. So I'll write the steps out over here now. Now, the confidence interval is what? Lower bound, comma, upper bound. So I'll write that in between. That would be what the confidence interval is going to be. Now I'm going to write what the interpretation would mean in the context of this problem. We are 95% confident that the proportion of music teachers that said video games like Guitar Hero and Rock Band have a positive influence on music education is between 0.744 and 0.815 inclusive. Now, let's show you how to put this into the calculator. All right, so how do we put this in the calculator? It's stat, highlight tests, and we're going to scroll all the way down. At least for my calculator, it's letter A. And we're looking for one proportion Z interval. That's what we want. Hit enter. The X in our particular case, that's 403. Hit enter. N is 517. Hit enter. The level of confidence is 95%, but you need to write it as a decimal, so that's 0.95. Hit enter. Highlight, calculate, hit enter. And notice what we end up having. On the top is your confidence interval. Now keep in mind, I will round all confidence intervals to 3 decimal places. So that's going to be 0.744 to 0.815. All right, I'm going to write on the paper now what I would expect to see for a test. Okay, so what do I want you to write? One prop Z interval, parenthesis, 403, comma, 517, comma, 0.95, and then underneath is my confidence interval for this. Okay, let's take a look at part B. A video game manufacturer claims that 80% of music teachers believe that Guitar Hero and Rock Band have a positive influence. Does the confidence interval support this claim? Well, is 80% somewhere in this confidence interval? Well, clearly that's in between 74.4% and 81 5/10%, so the answer is yes. So let me write out the explanation now. So this is yes, since 80%, which is equal to 8/10, is contained in the confidence interval. Okay, let's take a look at part C then. Determine the margin of error for this. Well, the margin of error, you have 2 different ways to look at this. And I'm going to write both scenarios down now. You can either write it as the upper bound of the confidence interval minus p hat, or p hat minus the lower bound, because remember, p hat should be right smack in the middle. So I can write it like this. Or this. So in either case, that is my margin of error for this. Okay. So do the previous example using a 99% confidence interval. What do you notice about the margin of error? Okay, so first off, the conditions have already been met. I did that on the previous page. So what am I going to put in the calculator? So 1 prop Z interval, it'll be what? X, comma, N, comma, the percent confidence as a decimal. Okay, let's put that into the calculator now. Okay, so let me show you again where to do this. Go to Stat, go to Tests, and again, we're going to go down to A, 1 prop Z interval, hit Enter. So the 403 is there, the 517 is there, and I'm going to change this to 0.99, hit Enter. Highlight Calculate, hit Enter. So here, rounding it to 3 decimal places, that's 0.733 and 0.826. So let's put that on the paper now. So here is my confidence interval. Now, let's do the margin of error for this. Okay, so you can either do the upper bound minus p hat or p hat minus the lower bound. Well, the upper bound is 0.826. Let's go back to the calculator and see what p hat is going to be. So notice p hat, and I'm going to round it to 4 decimal places. I'm going to write 0.7795. So let's put that on the paper. So putting in, and we get 0.047, or do the p hat minus the lower bound, and we get this. Now, the error in the last example was this. So it looks like our error is greater than. So let me write out the conclusion for this. The margin of error increases as the percent confidence increases. And this works in the other way also. The margin of error decreases as the percent confidence decreases also.